So this is question 30 from 2020 June 2020 mathematical science paper. A is given a 2 by 2 matrix with determinant and the trace value are given. We have to find the value of A square, the trace of A square. So it is a real matrix. So if we write the characteristic equation of A in terms of trace and determinant, lambda be the eigenvalue, so lambda square minus trace of A lambda plus determinant A is equal to 0. Put the value of trace, that is minus 3 lambda plus 1 equal to 0. So here we have two eigenvalues, lambda 1 and lambda 2. Lambda 1 is 3 plus root 5 by 2. Lambda 2 is 3 minus root 5 by 2. We have to find the value of the trace of A square. So for A square, the two eigenvalues will be lambda 1 square and lambda 2 square. We know the trace of A square is nothing but the summation of the eigenvalues lambda 1 square plus lambda 2 square. Put the values of the lambda square over here. Lambda 1 is 3 plus root 5 by 2 whole square plus 3 minus root 5 by 2 whole square. The summation will be 7. So the value of the trace A square is 4. Option 4, that is 7. So this question number 31, for AB belongs to this real space. P is given, P of xy. Equation is given. We can see that an x and y have 2 points that belongs to the space R2. So we have to find for what values of A and B that does this bilinear transformation define an inner product. So the P is, you can see this bilinear transformation is bilinearly transformed. So let us consider, you have to map this from R2 cross R2 to real space. And we have to define whether this is define an inner product, and in that case what will be the value of A and B. So let us consider, so let P is equal to the two bases is there, E1 and E2. So B the standard basis is of R2. So matrix representation of P will be in matrix form. So let us consider a matrix A. So P of EI, this is the two bases, standard basis EI and EJ. A of IJ. So let us consider a matrix. So A of IJ, I of this a 2 by 2 matrix, A11, A12, A21, A22. This is a 2 by 2 matrix. If we put the corresponding this particular elements of the matrix in the representation of P, So we can write it as P E1 comma E1, E1 comma E2, E2 comma E1, and this will be P E2 comma E. Right? So we have considered that E1 and E2, these both are the standard basis. So for this case, E1 is the 1 comma 0 and E2 is 0 comma 1. So the standard basis of R2. So we have given the equation as the following equation can be represented similarly in the matrix form as A square AB AB B square. This will be the matrix representation of A, and this is a symmetric matrix. Okay. A symmetric matrix, to be positive definite, it has to be all eigenvalues are non-negative. So this is the condition we know, are non-negative. This is the, and it should be all eigenvalues should be positive. So if we find that the determinant of A is A square B square minus A square B square equal to 0. So from this we can infer that at least one eigenvalue is 0. So in this case, though it is a symmetric matrix, but A is not positive definite. Since A is not positive definite, so it cannot, this P cannot define an inner product. So P cannot define an inner product. P cannot define an inner product. So there should be no value of A and B for which it can define an inner product. So the option number 4 is the correct option for no values of A and B. Question number 32 says, which of the following real quadratic forms on R2 is positive definite out of the 4 options? So let us write the general form of a real quadratic. General form of a real quadratic form on R2. So you can write in Q of xy as ax square plus by square plus 2 cxy. Corresponding matrix representation is A, C, C, D, 2 by 2 matrix. And this to be symmetric matrix and positive definite. which is the to be positive definite, we have to be d1 should be greater than 0, d2 should be greater than 0. So in this case our a is greater than 0 and ad minus c square is greater than 0. So we can say that this is symmetric and positive definite. So let us check with the options one by one. So first option is the q of xy. So the corresponding matrix representation will be 0, half, half and 0. So xy can be written in the matrix representation. So d1 is 0, which is not greater than 0, not positive definite. Option 1 is wrong. Let's check with option 2. X square minus, so this is option is xy. So there is no 2, there is a optional error is there, printing error. x2 minus xy plus y square, and the corresponding matrix representation will be 1, half, minus half and 1. So d1 will be 1, which is greater than 0, and d2 3 by 4, which is also greater than 0. So this is a positive definite. So in our example, the option 2 is the right option. Let us check with the remaining option 3 and 4. Option 3 is given this x square minus 2 of xy plus y square. Corresponding matrix representation will be an identity matrix. So here d1 is greater than 0, but d2 is itself 0. So it is not a positive definite. Option 3 is also incorrect. The last option, x square plus xy, option 4. So the corresponding matrix representation will be 1, half, half, 0. So d1 is greater than 0, it is 1, but d2 is coming minus 1 by 4, which is less than 0. So it is also not positive definite. So option 4 is also incorrect. So option 2 is the only correct option for this question number 32.